video is about solving linear systems algebraically. Substitution is an algebraic method for solving a system of equations. A system of equations is when you have two or more equations and multiple variables that you're trying to solve for. So here we have x and y in both of these equations. We're not done until we solve for both x and y. So there's only one unique answer for x and y that's going to make both of these equations true, and that's what we're trying to find. In the substitution method, you want to make sure that one variable is already by itself in one of the equations. And I see here that I have this y by itself already in the second equation. Y equals the entire quantity negative 2x minus 6. That's what y equals. If y equals negative 2x minus 6 in the second equation, then it also equals that in the first equation. I'm taking this as a set. So I can replace the y from the first equation with this entire quantity negative 2x minus 6. So I'll rewrite my first equation, negative 3x plus where it used to say y, I'll replace it in parentheses with this quantity equals negative 1. And now I have an equation with only x in it, and I can solve equations that have only one variable. So negative 3x, let's get rid of these parentheses. Combine like terms over here, move the 6 to the other side. Divide on both sides and x equals negative 1. Now we're not done when we solve for x. We have to go back and figure out what is y if x is negative 1. We're going to go back to one of the original equations. The easier one to use is the one that already has y by itself. And we're going to plug in our answer for x. So it says negative 2x. So we'll write negative 2 parentheses, replace it with the negative 1 that we found for x, and then just simplify this right side of the problem. Negative 2 times negative 1 is 2, and 2 minus 6 negative 4. We want to write our final answer every time we get an x and y as an ordered pair. X comes first, then y, we're going in alphabetical order. We write it in parentheses with a comma between it. That's what I mean by an ordered pair. All right, so our solution is negative 1, negative 4. You could plug that x and y back into both equations to check if it works. This one has an extra step right at the beginning. We still are asked to use the substitution method, which means something needs to be by itself, and nothing is. But if you look at the two equations, it's clear that the y in that first equation is going to be the easiest thing to isolate. It has only a 1 in front of it as its coefficient, and it's pretty simple to get that y by itself. So I'm going to take that first equation, 5x plus y equals 4, and rearrange it so that y is the subject, so that y is by itself. So subtract the 5x to move it to the other side, and y equals negative 5x plus 4. Now I have y by itself. Y equals the quantity negative 5x plus 4. And so I can take this and plug it into the other equation in place of y. Got to be careful to use parentheses when I substitute, because there is a minus 3 in front of it that's staying. Then where y was in the parentheses, I'm replacing it with the whole quantity, negative 5x plus 4, and then equals 5. Now I have an equation with only x in it. Distribute the minus 3. Combine like terms. Over here we have 17x. I'll add this 12 to the other side. X equals 1. When you obtain 1 for x, you have to go back and plug it in to obtain y. Doesn't matter which equation you use. In fact, you can use this equation, which is the one where you've already got y by itself. It's just a rearranged version of the original equation problem. So I'll use this when I'm going to plug in my 1 for x. Simplify the right side of the equation, negative 5 plus 4. So y equals negative 1. And write our final answer as an ordered pair. X was 1, y was negative 1. These two are the special cases that you might run into. So I'm going to try to solve it by substitution. I already have y by itself. I'm going to plug it in for y in the first equation. Try to solve this equation for x. You'll notice that if I combine like terms here, 4x minus 4x, they cancel each other out. And I'm left with 2 equals 5, which we know is a false statement. So if your x drops out and you're left with a false statement, that means there is no solution that works for both x and y. There is no solution. If you were to look at those two lines on a graph, you know that an equation that has x and y in it is just a line on the graph. If you were to look at those two lines, it would be something like the first line might look like this, and the second line would look exactly parallel to it, and those two lines never cross. They never share an x and a y point. Therefore, there is no solution for where they would intersect. The second equation over here when I try to substitute this in for y, and then solve the equation, 6x minus 6x plus 4 equals 4. The 6x minus 6x cancels out. 4 equals 4, which we know to be a true statement. And this time, because 4 equals 4 is a true statement, we're going to write that there are infinitely many solutions. Infinitely many solutions. The answer is not all real numbers this time. When we solve a linear equation for x and we get a true statement, if you're just solving for one variable, you would write all real numbers as your solution. Because we're solving for two variables here, what these two lines would look like if you graph them is the first line might look something like this, and the second line, I'm switching colors here, I'm going right over it. It's exactly the same line on top of itself. That means that they overlap at every single point. Here they overlap, here they overlap, here they overlap. Therefore, there are an infinite number of solutions where they overlap. You don't, however, want to say all real numbers because there are points over here and over here that wouldn't count as solutions to this equation or this system of equations. So you want to say that infinitely many solutions exist without saying what those solutions are. Then there's a second algebraic method called the elimination method. This is a really good one to learn, most people's favorite, and it's often the quickest and the easiest way to solve these. It's sometimes called the addition method or linear combinations, and it works best if both of the equations are in standard form to begin with. That means the x term comes first, and the y term, then the equal sign, and then a constant number. So if you look at both of these equations, that's exactly the order they're in. X term, y term, equal sign, number. Looking at the two equations as a unit together, you see that there's 2y in the first equation and a negative 2y in the second equation. And if I was to add these two equations together, the 2y and the negative 2y would actually cancel each other out or eliminate, which is why this is called the elimination method. So I'm going to actually do that. Add these two equations together vertically. 3x plus 4x is 7x. The two y's cancel out, and 4 plus 10 is 14. Now I have an equation with only x in it, which I can easily and quickly solve. And that's how fast we came up with x equals 2. Of course, you do have to go back and plug it in to get y. So I'll take either of the original equations, plug our x in for x, and then isolate the y. And then write your final answer as an ordered pair, x, comma, y. And that's as easy as it gets. There might be an extra step that you have to do at the beginning. For example, still wants us to use the elimination method here, but nothing eliminates. Nothing cancels out. A 3x and a minus 4x will not cancel each other out. A 6y and a 7y are not going to cancel each other out. And we can't use this method unless something eliminates, right? We don't want to just add them together and still have x and y. So in order to make something eliminate, I'm going to go ahead and make the x's eliminate. I'm going to have to use multiplication. I'm going to multiply the first equation by something and the second equation by something so that the coefficients of x will match and will cancel out. So since the first one says 3x and the other one says negative 4x, I'm going to multiply the first one by 4 and the second one by 3. Then my first equation will start with a 12x, and my second equation will start with a negative 12x, and those two numbers will cancel out. So distribute your 4 through the first equation. 4 times 3x is 12x. Don't forget to distribute it to everything in the equation. Often we forget to distribute it to the last constant term on the other side of the equal sign. Distribute the 3 through the second equation. And 3 times negative 16. Sometimes the numbers get a little bit big, but not too big to deal with. We want to now add the two equations together, and you'll see that the 12x and the negative 12x eliminate. Negative 24y plus 21y. And 36 plus a negative 48. We have an equation now with only y in it, and we can solve for y equals 4. We're just going to have to take that 4, plug it back into any of the equations that we've dealt with so far here to figure out what x is. So we can take this first equation, 3x. Remember to replace the correct variable. We solved for y, so I better replace y. I will add 24 and x equals 11. Write our final answer as an ordered pair. And I can always take it, plug it back into both equations to check that it works. And there are special solutions when you solve with this method too. You'll see that it falls out the same way. I have the x's won't eliminate, the y's won't eliminate, so I'm going to try to go for the x's and multiply this equation by 2. If I multiply the first equation by 2, it becomes 4x negative 6y equals 8. The second equation already has a negative 4x, so I don't need to multiply it by anything to make the x's eliminate. And you should notice something special is going to happen here when we try to add these two equations together. 4x minus 4x cancels. Negative 6y, positive 6y cancels. There is 0 left over here. Equals 8 minus 8. Those actually cancel, and there's 0 left over here as well. 0 equals 0 is a true statement. And remember, when we get a true statement, because there's two variables, we're going to write that there are infinitely many solutions. These would be two lines that overlap everywhere. And if, in a separate example, let's say the 8 and instead of minus 8, if this had said minus 10, and 8 and a minus 10 does not equal 0, right? That would equal negative 2. And if you get a statement like 0 equals negative 2, well, then that's false, and you would write no solution. So pay attention to whether your result is true or false. So you either write infinitely many solutions or no solutions to the special cases. And that is all.